to meet you. It's very important that the theme of green energy becomes so popular in Russia. It's very good for us and all over the world. And the one question for you, the problem of wind turbine blade recycling has been considered of higher relevance for a long time because utilization in the wind industry is often called by critics as not entirely green. What was the main reasons for the technology proposed by Vestas, and what kind of efforts were very important? Organizational capabilities to combine efforts from the wind energy, chemical industry and science, or maybe a completely new level of development of science was required for this process?
Yes, I think it's very important to say that when you look at a wind turbine, it's primarily made of steel. That makes a wind turbine between 85 to 90% recyclable. So by far most of a wind turbine can be recycled. I think that's very important to emphasize. Then we have the remaining part, and that is the blades, and they are made of composite. And thank you, Kemal, for your introduction. That is a big challenge. And the big problem is when you put the resin and the fiber together, then you have a component that's hard to disassemble at end of life because you have designed it for a long life. It's very robust, and that makes it hard to recycle again. So thank you, Oksana, for the question. That was a pleasure, and I'm happy that you mentioned or you referred to the technology that we are developing here, and that is the CTEC project. And in CTEC, we do have a technology where we can separate the fibers and the fibers and the resin at end of life in very mild conditions. And then we've developed a technology so that we can take the resin and in a catalyzed process get back to the basic raw chemicals of the epoxy resin and then use these in a new blade. So that is entirely recyclable. And because we do it with a catalyzed process, and we do it in mild conditions, the separation of fiber and resin, it's not that expensive to do. So it would also be easy for us to have a service that can do it, and other companies working within composite recycling, they can pick this up and do it. So you don't have to transport the blade far, you can do it locally. So that's like the thoughts behind the CTEC project. It's not a completely new level of science, but it's a completely new level of thinking resins. So it is add-ons and new design of the epoxy matrix we are doing. That's important to say, but not on a level so that we are questioning the robustness in use, or not on a level so that we have completely new physical or physical properties of the resin.
Thank you. You said about the long life of wind turbine blades, and it's very interesting how long its life.
Yeah, I think most of our wind turbines we sell today, they go for approximately 30 years. I know that some goes for 40 years, and from an environmental perspective, that is actually the best thing you can do. That is to have a very long lifetime on the products.
What can you say about the carbon footprint from using this technology? It's a good situation if the wind turbine will be 100% recycled. But to what extent the turbine blade recycling process will be carbon neutral?
I mean, if you're looking into the future, then you would prefer to use electricity that are made from renewable resources. So let's say that you have renewable resources, then that by nature more or less would be carbon neutral. So if you get the electricity to drive this process from wind turbines, that's carbon neutral. And then you also touch directly into the heart of this project, because it is about keeping the carbon in the loop. So it is about keeping the molecules the carbon molecules in the resin in the loop. And instead of letting these escape as CO2 at the end of the day, because you incinerate, you burn off the resin, then instead you use it again and again and again in a circular fashion. So that is the circularity part. And to run that circularity part, then you need electricity, and that can come from renewables.
Allan, how significant is the issue of utilizing wind turbine blades if we compare this process with how many composite materials are used and utilized in other industries? Maybe the wind industry is wrongly criticized for this. And what significance it has for other sectors of the economy?
Composites is important to a lot of sectors and a part of many sectors. And if you have a look at waste, composite waste from other sectors, then the wind turbine industry will be in the many years very low on that scale. So industries that uses more composites will be construction industry, it will be automotive industry, it will be the marine industry, and it will be the electronic industry. So these four industries use more composites than the wind industry.
Okay, for now the technology under the token belongs to the Vestas. Will it be possible to transfer its know-how on a global scale later on?
Yes, and that is actually the plan and the ambitions with this project, because if we get success in the CTEC project, then it's about making that technology available to everyone who is making epoxies. Because if you get scale, then these epoxies will be cheaper to Vestas because you produce more of it. It'll also be much more easy to actually recycle the composite at end of life, because the more of this composite that's on the market, the more attractive it will be to recycle and get back into the loop. So scale is king. It's king because it'll make the product cheaper, and it's king because it will ensure that it's actually recycled.
And what do you think about the alternative technology solutions, not Vestas technology?
I'm really happy to see that other companies are developing solutions where they think recycling into materials. And I think this one about thinking circularity into to polymers, to new materials, I think that's the right way to go. And I'm really positive about other companies doing the same. And I guess that is a race. So let's see who will win at the end. But no matter what, thinking new alternative technologies that can be recycled, that I'm very positive into that. Also, when it is competitors who are doing it.
Is all we're talking about applicable and for all Russia? The Russian segment of wind energy industry is developing quite intensively with the direct involvement of Vestas. Can we say that the problem of recycling wind turbine elements becomes irrelevant for Russia, since it will be solved in the nearest future with the support of one of the largest players in the country's wind energy market?
I think it would be a huge shame if I have to put focus. I have to emphasize that the CTEC project is still a technology project. So we're still doing technology. We are very far in the project, and we are. The chance it's getting a success is high. But no matter what, Vestas is going to provide a recyclable blade in 2030. And that will be applicable globally. I mean, especially in Russia, you have a very beautiful nature, and it would be a shame if you are not allowed to use this technology as all other countries having wind industry. So that is equally applicable in Russia. So it'll compared to elsewhere in the world.
And the final questions for you. Say, please, Allan, do you believe for the big future of the green energy, for the renewable energy in the world and in Russia too? Do you believe in this process?
If I believe in the process that we will have more renewable energy.
Renewable energy, only the energy of sun, the energy of wind, the energy of rivers. Is it very important for Russia and for all the world?
Yes, I think it's very important that we get renewable energy. We need have energy sources with much less CO2 and move away from coal and oil to a large extent. How the mix is going to be between nuclear facilities and wind and hydroelectric power, I don't know, but I guess there will be a mix between these three, and that's fully acceptable. Each of them have their strength to take peak forces as base loads for different parts in the country, especially if you talk about Russia, that is that big. There could be advantages having wind turbines some places, nuclear other places, hydroelectric those places where you can get that. That is the way we need to go. It goes hand in hand. These zero carbon electricity technologies.
Thank you very much, Allan, and we do hope to see you in Russia. So next year,
I would love to go to Russia.
We will make a big, or actually the biggest forum related to renewables, and it will be not in Moscow. So we all decided we go to Rostov, to the south of Russia, where today is the southern federal district of Russia is unique because it's 30% of the electricity there, 30, is produced by renewables. It is, I mean, not too much for you in Europe, but for us, it is incredible figure because overall renewables for Russian energy system is like, Dmitry, correct me if I'm wrong, like 1.5 up to 3%, yeah, overall. Yeah. But then in the south of Russia, the renewables are dominating, solar and wind. So this year we crossed, as Vestas, we crossed 1 gigawatt of installed capacity for Russia. We crossed our equator. For us, it's an important milestone. And actually, the most of those 1 gigawatt, practically 99%, is installed on source. So, and then we will have in May, we will have a big event there. So we invite you, Allan. So I will arrange a special communication because there it will be exactly this professional discussion about all this stuff.
Yeah, I would love to go there. I would love to go to Russia. So that's that's on my wish list.
That's why we are waiting for you in May in Russia, in Rostov.
I would love to go there, definitely.
Okay. Yes. Thank you very much, Oksana. I will download the recorded video and then we will make a movie. Allan, I will send the final version for the confirmation.
Yes. Thank you. Take care. Spasiba.
Thank you very much.
Thank you. Bye.
Bye.